Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain you about the chemical kinetics chapter, one of the important chapter for the JEE mains and even for the NEET level and advanced level also. Every year at least one or two questions they are going to ask from the chemical kinetics chapter. Okay. So now let us see the previous year question analysis. Okay, when you see the previous year question analysis, at least one question is there and more than one also we can find out. At least one or two questions they are going to be asked. Okay, so very important chapter for the JEE mains. Next, let us see what are the topics we are going to be cover in this video. So we are going to cover mainly about the what is the rate of reaction, classification of reactions based on the speed of reaction, and average rate, instantaneous rate, and also we are going to cover rate of formation, rate of decomposition, and relation between the rate of reaction, rate of formation, and rate of decomposition. Okay, so let us start with the definition of chemical kinetics. Okay, so what is a chemical kinetics? Chemical kinetics, it is a branch of physical chemistry. It deals with mainly about the rate of a chemical reaction and factors which influence on the rate of reaction and the mechanism by which the reaction proceeds. Means we will discuss about the rate, what is the rate of reaction and factors influence and mechanism. First let us see what is the meaning of a rate of a chemical reaction. Rate of a chemical reaction. Okay, so what is the meaning of a rate of chemical reaction? Within how much speed the reactant is going to be converted into product, or within how much time the reactant is going to be converted into product, that is called rate or speed of reaction. Okay, so how we are going to define the rate of reaction? Okay, reaction rate or rate of reaction. Okay, so here generally in a chemical reaction the reactant is going to be converted into product. So here how much time it is going to be take to convert a reactant into product. Okay, so the amount, the time required, the required time required for conversion of conversion of conversion of a reactant, a reactant reactant into product, into product, that is called what, children? Rate of reaction. Okay, so how we are going to express mathematically the rate of reaction? Okay, so we express mathematically rate of reaction. So here rate equal to, rate or speed equal to change in concentration, change in concentration by change in time, change in time. So this is the rate of reaction. Okay, rate or speed of reaction. In general, for an automobile also, or a car or bike also, we express the speed. How we can express the speed? The distance covered in the given time. And here for chemical reaction, how we are going to express the rate? By calculating the change in concentration in the given time. So based on this we are going to calculate the rate of reaction. So here change in concentration we are going to consider as dx, change in time we are going to consider as dt, or else you can consider delta x by delta t. Okay, this is the rate of reaction. Okay, so you might have learned about the thermodynamics. Thermodynamics will give information about the reaction, whether the reaction is going to be takes place or not at given set of conditions. At given set of condition, if the reaction is takes place, that is a spontaneous reaction. The reaction not takes place, that is a non-spontaneous reaction. Means thermodynamics will give us whether the reaction is spontaneous or not. But chemical kinetics will give us information how much time it is going to be required if it is a spontaneous. See, for example, carbon. So carbon diamond to carbon graphite. Carbon graphite. If you take this reaction, here delta H equal to positive. Delta H equal, not positive, delta H equal to negative. Means it is a spontaneous reaction according to thermodynamic data, but thermodynamic data will not give us how much time it is going to be required. But generally, when you measure the speed of this reaction, it is a very slow reaction. It will take years together, even millions of years also it can take to convert a diamond into graphite. Okay, so hence we are going to consider almost is a non-spontaneous reaction. Okay, that is the major difference between the thermodynamics and chemical kinetics. Okay, so thermodynamics will give whether the reaction is spontaneous or not. Chemical kinetics will give how much time it is required for the reaction to complete. Okay, so that is nothing but rate of reaction. Okay, next let us see type of reactions based on the speed or the rate. Okay, so there are mainly three type of reactions are there based on the rate or speed. Okay, so what are they? They are the instantaneous reactions or very fast reactions, and the second one is very slow reactions, and next reactions having moderate rate. Okay, so these are classified based on what? Time required for the completion. Okay, first let us see. So these are classified based on time time required time required for completion or based on the rate or based on the velocity of the reaction. Okay, first let us see instantaneous reactions. Okay, so what are the instantaneous reactions? We know instantaneous reactions are also called very fast reactions. What is the meaning of very fast reactions? The reactions which can complete within fraction of seconds. So in 10 to the power of minus 12 to 10 to the power of minus 16 seconds. Okay, in that fraction of time only they are going to be complete. Means when you blink your eye also, in that time only they are going to be complete. Means in that fraction of seconds only the reactant is going to be converted into product. Okay, so let us see some examples for the very fast reactions. Okay, first let us define the very fast reactions. Okay, what are the very fast reactions, children? The reactions which completes the reactions which completes within fraction of seconds, within fraction of seconds, Okay, such type of reactions are called very fast reactions. Okay, so now let us take the example for very fast reactions. Okay, what are the examples we can give? For example, neutralization reaction. You know what is the meaning of neutralization? When a acid and base react together, they produces salt plus water. Such type of reactions are called neutralization reaction. So neutralization reaction between strong acid and strong base, between strong acid and strong base and strong base and strong base. So these are only very fast reactions. Okay, what is a uh, neutralization? We know it is a reaction between the acid and base to produce salt and water. See here, you remember all neutralization reactions are not very fast reactions. The neutralization reactions which occur in between a strong acid and strong base only are what? Very fast reactions. Okay. So see, for example, you can take NaOH. We know NaOH is a strong base and HCl. HCl is a strong acid. Okay, it will give us NaCl plus H2O. NaCl plus H2O. So it is a very fast reaction. Within fraction of seconds only, when you mix the sodium hydroxide with HCl, it is going to be produced immediately NaCl and H2O. And next, explosion reactions. Explosion reactions. Okay. So explosion reactions also very fast reaction. For example, explosion of TNT. Example, you can take TNT. TNT is the trinitrotoluene. Trinitrotoluene. Okay. So this is the structure of trinitrotoluene. Okay. This is the trinitrotoluene. So this is the example of for explosion reactions, and you can take the ionic reactions, ionic and precipitation reactions, precipitation, ionic and precipitation reactions. Okay, here ionic reactions also very fast reactions. Say for example, you can take example reaction between the NaCl, sodium chloride, and AgNO3, silver nitrate. Okay, so here we are going to take the aqueous solution of sodium chloride and aqueous solution of silver nitrate. Okay, so we are going to take. So when you mix them, immediately we observe formation of a silver mirror color precipitate, that is nothing but silver chloride. AgCl, silver chloride precipitate is going to be formed, and it produces NaNO3, one more compound, that is sodium nitrate in the aqueous state. Okay, this is the precipitate. Okay, what is the meaning of precipitate? Precipitate is nothing but, children, it is a insoluble solid, a solution, that is known as precipitate. Okay, so these are the examples of what? Very fast reactions. Okay, what are the very fast reactions, children? The reactions which completes within fraction of seconds. Okay, they are called very fast reactions. Some of the examples I listed here. Okay, what are these? Neutralization, explosion, ionic and precipitation reactions. Okay, next let us see very slow reactions. Okay, what are the very slow reactions? Very slow reactions means, children, the reactions which takes days, months, years together. Okay, the reactions which takes days, months, years together, such type of reactions are called very slow reactions. Okay, so how we can define the very slow reactions? The reactions which takes which takes days, months, years together, such type of reactions are called very slow reactions. Okay, so what are the examples of very slow reactions? Okay, let us take the some examples for very slow reactions. For example, you can take the rusting of iron, rusting of iron. Okay, So rusting of iron. So when you keep the iron nails or freshly prepared iron at the atmospheric conditions, a formation of brown color layer we are going to be observed, that is known as what, children? Rusting of iron. And you can take the decomposition of, or okay, or else you take the reaction between the CH4, not this, okay, the decomposition reaction, sorry, not formation of water, you take H2 plus half O2. H2 plus half O2 is gives rise to 2H2O. H2 plus half O2 is gives rise to 2H2O. And we can take the combustion of coal. C plus O2 is gives rise to CO2. Okay. So these are the some examples of what? Very slow reactions. Okay. You can take the rusting of iron and formation of water and the reaction between the carbon and oxygen to form the carbon dioxide. Okay. So these are the some examples of very slow reactions. Next, you come to the one more category. Before that, what is a very slow reaction, children? The reactions which takes days, months, years together to complete. Such type of reactions are called very slow reactions. Okay. Next, let us see one more category. The reactions having moderate rate. Okay. What are the moderate reactions? So these are also called moderate reactions. Okay. So now how we can define the moderate reactions? We know what are the very fast reactions, what are the very slow reactions. Okay. Now let us define the moderate reactions. The reactions which takes minutes, hours to complete. Such type of reactions are called moderate reactions. Okay. The reactions, okay, the reactions which take the reactions which takes minutes or hours to complete such type of reactions are called moderate reactions. Okay. Say for example, okay, example you can take for moderate reactions, you can take decomposition of H2O2, decomposition of H2O2, okay, decomposition of H2O2 or hydrogen peroxide. So now here H2O2 is gives rise to H2O plus half O2, H2O plus half O2, and inversion of cane sugar. You can take one more example, inversion of cane sugar. Okay, inversion of cane sugar, Okay. So what is the meaning of inversion of cane sugar? Inversion of cane sugar means, children, the sugar molecule C12H22O11 is gives rise to, in presence of water or acidic medium, is gives rise to C6H12O6 plus C6H12O6. Okay. So this is the inversion of cane sugar, which is a example of a moderate reaction. And H2 plus Cl2 in presence of sunlight, it will give 2HCl. It is also a moderate reaction. And you can take the number of examples. Okay, like H2, I2 plus H2. I2 plus H2 is gives rise to 2HI, okay, etc. Okay, these are the examples of what? Some of the examples of moderate reactions. Okay. Next, we are going to see the reaction rate. Okay. So up to now we have discussed about the what is the rate of reaction, what is the general definition of rate of reaction, and classification of reactions based on the time required for the completion. Okay, so now let us come to the reaction rate. Okay, so reaction rate, this is the mathematical expression of reaction rate, that is change in concentration of reactant or a product and the time taken for the change. Okay, so next when you come to the units, what are the units of rate of a reaction? So here concentration we are going to take, means generally molar concentration here we are going to take. So molarity per liter or capital M time inverse. Okay, or concentration here you can take mole liter inverse time inverse. Okay, these are the concentration units and these are the time inverse units. Okay, time inverse. Okay, and here when the reactants are present in the gaseous state, for example you can take N2 plus 3H2, N2 plus 3H2 is gives rise to 2NH3. So now here here we are having the reactants and products in the gaseous state. Okay, so in such case, what are the units of rate? Atmosphere per second or atmosphere per minute. Okay, these are the units of what children? Rate of reaction. Okay, clear? Next we are going to see the type of reactions. So type of rates. Okay, generally we are going to call them as the type of rates. So we are going to calculate two type of rates. One is the average rate, another one is the average rate of, another one is the instantaneous rate. Okay, so rate we are going to calculate in two ways, that is average rate and instantaneous rate. Okay, so what is the average rate and what is the instantaneous rate? First we will see average rate, means rate we are going to calculate in two ways, that is average rate and instantaneous rate. Okay, so what are this average rate and what are this instantaneous rate? So before knowing that, so we should know one more important thing, that is laws of chemical kinetics are applicable for only for moderate reactions but not applicable for the very fast reactions and very slow reactions. Why? Because in case of very fast reactions we are unable to measure the rate also, and in case of very slow reactions even though you measure the rate there is no use. That's why we are going to apply only for the moderate reactions. And while calculating the rate of reactions we are going to calculate in two different methods, that is average rate and instantaneous rate. Okay, so what is the major difference between the average rate and instantaneous rate, means children? In average rate we are going to take the large change in concentration and large change in the time. But whereas in instantaneous rate, at a particular time only we are going to calculate the rate. Okay, now let us see first average rate. Okay, so now here we are going to take the graph. So here this graph says that consider reactant is gives rise to product. Okay, we know as time proceeds the concentration of reactant is going to be decreased, and whereas the concentration of product is going to be increases. As time proceeds, concentration of reactant is going to be decreases. So now here let us consider, here we have taken the concentration of reactant. Okay, and here time we have taken. So as time increases concentration of reactant decreases. That's why we are getting a plot likewise. And here we are going to take at a time t1, at time t1 what is the concentration, that is A1. At a time t2 what is the concentration, that is A2. Okay, this is the A2 you consider. Okay, so now here what is the rate of reaction? Okay, so change in concentration, that is minus delta R by delta T, minus delta R by delta T. And in case of product, we know as time proceeds the concentration of product is increases. At initial time, what is the product concentration? There is no product at initial time, but as time proceeds the slowly the reactant is converted into product. Okay, slowly the reactant is converted into product, so that the concentration of product increases likewise. Okay, consider at the time t1 this is the concentration of product, initial concentration of product, or P1 you consider, and at this time T2, what is the final concentration of product, that is P2. Okay. So now here, what is the rate here? Rate equal to, okay, so rate, here also rate equal to, here also what is the rate equal to? Rate equal to delta P by delta T, delta P by delta T. Okay, this is actually, it is known as what, children? Average rate. Okay, so here consider a reactant is converted into product. Reactant is converted into product. So with respect to reactant, what is the rate here? Rate equal to minus delta R by delta T. Okay, so here we need to know one important thing here, why we are writing the minus sign. Okay, what is the significance of minus sign here? Okay, so here what is the meaning of delta R? Delta R. Delta R means that is final concentration of reactant minus initial concentration of reactant. Okay, final concentration of reactant minus initial concentration of reactant. Okay, so now we know already in a chemical reaction, as time proceeds, the concentration of reactant is going to be decreases. Okay, in a chemical reaction, as time proceeds, what will happen? The concentration of reactant is going to be decreases. Therefore, here R final is less than R initial. Okay, R final is less than R initial. So which means here less value minus more value, we are going to get the negative side. But rate never be a negative. Why? Because see, for example, a bike is there. It is going with a certain speed. So how we can say what is the speed of bike? Means it is 20 kilometers per hour, 30 kilometers per hour, like that we can say. But we cannot say minus 20 kilometers per hour, minus 30 kilometers per hour, like that we won't say. Here also the speed of reaction also we need to express in the positive value only. But here if you take without negative sign here, the delta R will get what? Negative value. So to convert this negative value into positive value only, we are multiplying with the minus sign. Okay, therefore negative into negative will become positive. That's why we are multiplying with the minus sign. Okay. Next, in case of product, rate equal to delta P by delta T, delta P by delta T. Okay. So here in case of product, why we are not writing minus sign means, children, here? So what is the delta P formula? Delta P is equal to, here also, final concentration of product minus initial concentration of product. Final concentration of product minus initial concentration of product. Okay. So here we know already here, in case of product, final concentration of product is more when compared to the initial concentration of product. Okay. So final concentration of product is greater when you compare to the initial concentration of product. Okay. So here more value minus less value. So here what we are getting? Positive. Okay. So means rate will get in the positive integers only. That's why here again you no need to multiply with the minus sign. Okay. Once again here, if it is the reactant, what we will do? We multiply with the minus sign. Why? Because final concentration of reactant is less than initial concentration. In case of product, final concentration of product is greater than initial concentration. Okay, these are the reasons. Okay. Next, let us see instantaneous reaction. Okay, instantaneous. Okay,